Tonight's lesson is on combining like terms using addition. There are two properties that I want us to review. The first property is the commutative property of addition, which states that you could change the order of an addition problem and still get the same answer. For example, 2 plus 3 is 5, and 3 plus 2 is also 5, so the answer stays the same. The second property is the associative property of addition, which states that you can choose which group you choose to solve first or simplify first. For example, on the left, we have parentheses, 2 plus 3 equals 5. If we bring down our 4, 5 plus 4 is 9. On the right side of the equation, we would start off with the parentheses 2 plus 4, which would get us 6. Bring down the 3, and 3 plus 6 is 9. The answer to the problem does not change. The last thing that we need to review is 5x. 5x is the same as x plus x plus x plus x plus x. If we count 1, 2, 3, 4, 5, we have 5 total x's. Combining like terms is like naming this couple. Their last name is like the variable or the letter that comes after the number. So 1 Smith plus 1 Smith would be 2 Smiths, or 1S plus 1S equals 2 S's. Like terms are called like terms are any terms that have the same variables. The simplest like terms are called constants or plain numbers. The terms 4x and 5x are like terms because each term has an x as a common factor. Simply add or subtract the numbers in front of the terms, which are called coefficients. So in this example, 4x plus 5x equals 9x's. If you take a look at this parentheses, there are 4 x's plus, in this parenthesis, we have 5 x's. If we count up all of the x's, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 9 x's. Some other examples of some like terms would be 2xy, 4xy, and negative 3xy. And the reason why these are like terms is because all three of these terms have exactly the same variable or last name if we're relating it back to the Smith family. This group of like terms has exactly the same variables. A squared, b to the third, a squared, b to the third. So they are considered like terms as well. Some examples of not like terms would be x squared and x. Even though they look the same, they look very similar, they both have x's, x squared is different than x. The same goes for 2x to the third and 4. 4 is our constant. So let's take a look at some examples. The first example says rewrite the sum of 5x plus 3x and 5x minus 3x by combining like terms. Remember, sum means the answer to an addition problem. So we will be adding these two sets of terms. I'm going to rewrite all of my terms, and I notice that I have 5x's plus 3x's, which gets us a total of 8x's. We bring down everything else. We now have 8x's and 5x's. So 8 plus 5, because remember, we're adding the coefficient. 8 plus 5 is 13x's. Bring down the minus 3. We're once again going to add the variables that are like terms. They both have x's. They are like terms. 13 minus 3 is going to give us 10x. So our answer for this problem will be 10x. Example number 2, it asks you to find the sum of 2x plus 1 and 5x. So we're once again going to rewrite 2x plus 1 plus 5x. And I'd like you to pause the video, try it out on your own, and come on back. Hopefully you paused the video and tried this on your own. Let's take a look. If I look, I notice that I have 2x and I have 5x. They are like terms because their variables are exactly the same. So we could combine them. Now, instead of having them separate, we are going to use the associative property to change, or excuse me, the commutative property rather. We're going to use the commutative property to rearrange the positive 1 and the positive 5x. And this will allow our variables, or our like terms, to be next to each other so that we can combine the 2x and the 5x to gain 7x plus 1. Now, if we look at 7x plus 1, 7x is one type of term, or one term, and positive 1 is a constant. We have a term that has a variable and a constant. So we are actually finished combining like terms. This is our final answer of 7x plus 1. And our third example is find the sum of negative 2a, of negative 3a plus 2 and 5a minus 3. So go ahead, write it down. And I want you to pause the video. Now, remember, we want to use the commutative property as well as the associative property to help us solve this. Go ahead, pause the video, and come on back. Hopefully you paused the video. The first thing that I want to do is I notice that we have positive 2 and positive 5a, and I would like to switch them. I'd like to use the commutative property to rearrange the order because remember, in addition, we are allowed to do that because of the property. So if I take a look, I have negative 3a plus 5a. These two terms are like terms because their variables are exactly the same. We're going to add the coefficients together, negative 3 plus 5, and that is going to give us positive 2a. Then I'm going to take a look at the second grouping of the constants, positive 2 minus 3. So if we add them together, I'm going to keep change the subtraction to a positive and negate the 3. Positive 2 plus negative 3. The signs are different, so we're going to subtract. 3 minus 2 is 1. We're going to keep the sign of the bigger absolute value, which is 3. So our answer is going to be a minus 1. 2a and negative 1 are not like terms. We have a variable in the first and a constant in the second. So our final answer is 2a minus 1. Okay. For the rest of the night tonight, I would like you to complete these 4 problems on your own. Bring them completed, come back to class tomorrow, and we will discuss them. Have a good night, everybody.